Hi guys, this is Mrs. Shepherd. This is your Unit 5 test review for addition and subtraction of fractions. Question 1. Jill baked 2 1/3 dozen carrot muffins for a bake sale. Mike baked 1 3/4 dozen apple muffins. How many dozens of muffins were baked in all? So we see we have a quantity here of muffins and a quantity here of muffins, and since we want to know the dozens of muffins in all, we need to add these two quantities together. So please set your problem up the way I am, vertically. So when it's time to get common denominators, you have room beside your problem to do that. So stop for a moment and see if you can figure this one out on your own. Then start the video again and check the solution. Okay, so common denominators for 3 and 4 you would do using a T-chart of multiples. And you can see 12 is the lowest number that appears in both lists of multiples. So we're going to use that for our common denominator. Next, we're going to think about the pattern that would be used to go from 3 to 12 if I were multiplying. And since I know 3 times 4 is 12, then I know I'm multiplying 1/3 by 4/4. That's a fraction that equals a whole. So the identity property says any number or quantity, such as 1/3, times a whole would give me the same value. So even though the denominator is 12, the fraction is equivalent. So we need to do the same thing up here with the numerator. 1 times 4 would be 4. So 1/3 and 4/12 are equal. I'm going to do the same thing with this fraction. And I see 4 times 3 would be 12, which means I'm multiplying by 3/3 to get an equivalent fraction. 3 times 3 is 9. When I add my two fractions together, I get 13/12. Now that fraction I know is greater than a whole because the numerator is greater than the denominator. It's more than 12/12, which would be a whole. So in order to make that fraction proper, I'm going to take out 12/12, which is a whole, and I'm going to take that over here and add it on to the whole number side. That would leave me with 1/12 as my fraction. And when I add up all of these whole numbers, I get 4 wholes. And when I bring that fraction over here to join it, I'm left with 4 and 1/12. So the correct answer should be D. Question 2. Matthew ran 3/8 of a mile and then walked 7/10 of a mile. Which pair of fractions can he use to find out how far he went in all? Well, the first thing I notice is that I'm looking for a fraction to show how far he went in all, which makes me think I need to add together 3/8 and 7/10. So I'm going to do the same thing I did with the other one, set them up like this. Now it doesn't actually ask me to add them, but it does ask me to find two fractions that I could use to add them. And since I know 3/8 and 7/10 have different denominators, the first thing I need to do is figure out what would the denominator be if I were adding them. So 8 and 10 are my two denominators. And I see that 40 is the lowest number that appears in both multiples list. That means I can rule out this choice because it's the only one that doesn't use that low denominator. And I need to look at the other two. Also want you to notice that A and C have the same exact answer, so I can eliminate one of those as well. That's a mistake on my part. So let's go ahead and see what we can do with these two fractions. So just like the problem before this, I'm looking for the number that I can multiply by to get that denominator. I'm going to use the same thing for the numerator, which would give me 15 as this new numerator. And now looking at my choices, A or B, it looks like A is going to be the answer. But I'm just going to finish this up real quick. 10 times 4 would give me 40, so then I know I'm multiplying by 4/4, which would give me a new numerator of 28. So these two fractions appear right here in choice A. Question 3. Roberto's cat weighed 6 3/4 pounds last year. Then the cat gained 1.5 pounds. How much does the cat weigh now? Okay, so when I look at this one, I notice a few things. The cat weighed this much last year and gained weight. So when someone gains weight, they're usually adding on some pounds. So if I want to know how much the cat weighs now, I'm going to have to add on 1.5 pounds to 6 3/4. So let's go ahead and set that up. Again, rewriting the problem vertically. I see I need common denominators, and you're going to be working through this on your own and then coming back to check your answer. Okay, so the first thing I need to do is make a t-chart of my denominators. And I don't have to go very far to notice that 4 is my new common denominator. The first fraction doesn't change at all. It's already in fourths, but my second fraction, I need to look for that pattern again, and I see it's 2 times 2. So I'm going to make a fraction that equals a whole and end up with 2/4, which is equivalent to a half. When I add my two fractions together, I get another improper fraction, 5/4. The numerator is bigger than the denominator. I know 4/4 would be a whole, so if I take that out, that whole, and bring it over here and add it on to the whole number side, I'm going to be left with 1/4 as my fraction. Adding up these whole numbers, I end up with the whole number of 8. Bring over my fraction, and the answer is 8 1/4 pounds. Choice D. Question 4. A red ant measures 8 millimeters in length. If you magnified the image by 8 times 10 to the third power, what size would the fire ant appear? Okay, so since we're taking a measurement and we're magnifying it, we know that that's going to be multiplied because it's going to become larger. So basically what we have here is 8 times 10 to the third power. And remember, 10 to the third power is the same as 10 times 10 times 10. 10 times 10 is 100, times 10 more would be 1,000. So we could rewrite this to be 8 times 1,000. 8 times 1,000 would be 8,000. 8 times 8 would be 64. And then we just have to pop on those extra 3 zeros. So the answer to this one should be D. Number 5. Carla is riding her bike on a trail that is 24.6 miles long. So this is how far she's riding. So far she rode 1/10 of the trail. That means I need to cut the trail into 10 parts. And we are looking for how much is one of these parts, because that's how far she's ridden so far. So if we want to know how far she rode, we need to take the size of the trail and divide that into 10 parts, and it's one of those parts that we want the measurement for. Remember, when we divide by a power of 10, basically we want this number that is in the tens place to move one place value smaller. So from the tens place, it's going to move to the ones place. That can be accomplished by simply moving the decimal point one place to the left. So the 2 is now from the tens place moving to the ones place. And the answer should be 2 46/100 miles. Boys and girls, I hope that was helpful. This is the video for just questions 1 through 5. Please look for 2 more videos to complete your packet.